Hey everyone, I'm John Lynn, the founder and chief editor at Healthcare IT Today, and we're excited to bring you another in our series of interviews with top leaders in health IT. And today's guest is Josh Rubel. He's Chief Commercial Officer for MDClone. Welcome, Josh.
Thanks, John. Great to be here.
Yeah, good to have you back on the show. This is kind of an extension of the conversation we started a couple of years back. But before we dive into LLMs and synthetic data, tell us a little bit about yourself and MDClone.
You bet, and it is a pleasure to be back. Always nice to reconnect with the team at Healthcare IT Today. So I'm Josh Rubel, like you mentioned. I'm the Chief Commercial Officer at MDClone. And MDClone is a software company that's really focused on enabling healthcare providers and their partners to get the most out of healthcare data. And really, when we talk about getting the most out of data, the lens to view us through is quality improvement, performance improvement, academic research, and third-party innovation opportunities where health systems can make their data available to industry and to other academic partners to find the next amazing innovations that may be uncovered through the use of that data. So the business is kind of heavily focused on making data useful. And so the topic around generative AI and LLM, I agree. It's the right conversation for us to be having, in particular with MDClone's unique technical capabilities of both simplifying how to do data extraction and also layering privacy preservation atop data with our synthetic offering that I think is likely what we're going to be talking about. So very excited to dive in.
Yeah, I mean, I think you do have a unique perspective as certified data nerds. I think is appropriate. Being extracting the data and understanding it, because when you talk about large language models, it's all about the data. So, what's your view on LLMs, right? Large language models in healthcare. How do you see them playing out?
So, I had a chance about a year ago to hear Peter Lee from Microsoft talk about what large language models could mean for the world of healthcare and how they work related to the creation of new knowledge. So the kind of essence of artificial intelligence. And it's fascinating. I kind of got a behind the scenes peek at what OpenAI was going to deliver to the market, maybe a month or two early, um, uh, at least conceptually. And it was amazing to hear kind of what the opportunity for AI looks like and how this one little small piece of how we can potentially generate AI might be transformative. So LLMs, probably the best way to think about them is taking the entire corpus of human thought that's been converted to text and leveraging that thought algorithmically to answer questions and or guide someone who's interested in exploring a particular problem they have, a particular subject area that they want to dive into, taking that corpus of human knowledge, again, that's been codified in text, and applying it to those questions in a conversational sort of way. And that's really what we've seen with Bard and with ChatGPT and with many of the other tools that have been kind of steadily rising in use here over the last 6 or 7 months. So that's what a large language model is. And it's pretty amazing when you think about it. It's maybe a better way to describe it is taking all of human understanding and then making that available to generate more understanding. It sounds like what a library is for, or if you harken back, if we're really being data nerds, this is the Great Library of Alexandria on steroids, right? I mean, you have as much knowledge that you can put in a box, and then you can apply it in an easy way. You can apply that knowledge to what your next set of questions will be to create more knowledge. In that respect, it's not necessarily AI. That vast set of knowledge that I was just describing has been aggregated over time since people have been able to write things down. And it's been passed on generation to generation. And man, we have gotten very good at writing things down over the last several thousand years. Now we can take all of that's been written and just apply it fast. That's not the AI piece. The AI piece is, okay, corpus of knowledge, give me new knowledge and react to me in a new context. Let's make use of that corpus that's where the AI comes in. And it's fascinating, really, in every part of our economy, every part of human interaction, and in healthcare, which is such a big part of our economy, and where there's so much potential value, especially knowledge projects, data projects. There's certainly applicability, and happy to dive in. I mean, think about the corpus of all human knowledge. You know, the part of it that's healthcare, it's not a small percentage,
Yeah.
John. It's probably
Right.
greater than 5% of all knowledge. Think about every research paper, right? Think about every medical journal, think about every article published, and then think about medical records. There's a ton of compiled text that happens to be focused on healthcare. And now all of that can be part of a large language model framework, as long as you get a couple of things right. It's got to be good data, and based on the relationship between patient and provider organization that's housing that data, it's got to be privacy preserved. And I think that's likely where synthetic comes in. So I'm happy to dive in. And anyway, as you can tell, it's a subject that's near and dear to my heart.
No, for sure. And there's a couple of things you said that were really interesting. The first one that I find interesting is that you talked about using it to discover new things. Whereas I actually think one of the coolest parts of large language models is actually bubbling up information and knowledge that's clear that people just haven't learned. Like, it's new to me, right? It's like when you buy a new car that's used, you're like, well, it's a new car to me. I don't know it, right? And I think that's what large language models do, is they often bubble up information that is knowledge someone else has, and it flattens that world and gives it to, imagine a new med student, right? Who obviously doesn't have the years of experience getting it. So anyway, I think that's an interesting element of it. Whereas net new discoveries is also interesting. I think it can do both, which is fascinating. The other interesting way is when you described it as just this body of human knowledge that it's going through. It reminds me of something someone said, and I've said it a few times on this podcast, is that when people talk about hallucinations, actually someone said that on the internet, probably, right? Like, it's actually not pulling necessarily and making stuff up, although there are some cases where it does. It's often them pulling up that a lot of people said something that was totally inappropriate. And I apply that to healthcare, and I think about how many clinical notes documented something wrong, or maybe prescribed the wrong thing in the wrong instance, right? Because they didn't have the knowledge they needed. We have that same problem with healthcare data, I think. So anyway, it's interesting to think about, right?
Absolutely. There's something our current president says, or used to say, related to elections. Are you comparing me to my opponent, or are you comparing me to the Almighty?
Hmm.
And where you're heading, is a derivative of that, which is, are you comparing me to the alternative, or are you comparing me to perfect?
Mm-hmm.
And I think it's the right lens to think about how these tools can be used. At the end of the day, what we want is better. Whatever we're working on, we want it to be better than it is now. And if the generative AI framework makes us better, smarter, faster, even with certain mistakes and inherent risks, it's something we've got to dive into, because that's the goal. The goal isn't perfect. The goal is better.
Yeah. Well, let's talk about synthetic data. You've kind of mentioned it, and we'll link to our previous discussion where we dove into it pretty deep as well. But how far have we come kind of in our use of synthetic data in healthcare?
I think we've come pretty far. When we spoke a few years back, we were definitely still in the conceptual mode. Since then, gosh, we've had 10 plus large scale provider organizations, including federal agencies in the United States and other government entities around the world, start to use synthetic output for things like large scale data challenges, or even much more secure, much more privacy preserved, defined research projects managed entirely by an internal team at a healthcare institution. Synthetic data, we've now been involved in thousands of projects around the world. And when we originally spoke, that number was probably more like in the tens, or maybe even the very, very low 100. right around there. I think we've now, the growth's been exponential, largely because the data is now more available. We have customers that use the synthetic output. So before it was conceptual, now it's, facts on the ground. These data are available and they are mineable. Related to kind of how it's progressed, the trick in the synthetic output is it's got to mirror reality.
Mm-hmm.
And there are lots of different ways potentially to do it. In our experience in healthcare, MDClone is a unique company. We can generate synthetic data on demand for a cohort of patients. Imagine that cohort has certain features that you're looking for, 10, 15, 20 some odd features. We can generate a synthetic data set on the fly that mirrors for that cohort of patients the features that you're looking for, mirrors it to the tune of good science, without any privacy impact, meaning it's an entirely privacy preserved data set. There is no real patient data in the output, but it tells the same story as what the real patient data output would have told. That's how our platform operates. And the ramification of kind of having many, many thousands of these now performed is that we've tuned it correctly. We are answering the question correctly, meaning the output does tell the same story as the original data, as the PHI, and confirmed. And again, in a highly regulated environment, places like the U.S. federal government with the VA, places in Canada that are, again, provincial, large-scale health systems with a ton of expertise in this. They have proven that the concept works. And of note, a challenge in healthcare with large language models and generative AI is, okay, what can you put in? What are you allowed to put into a large language model if you're looking for insights around a particular population? And of course, patient privacy is a big challenge. You cannot put PHI, protected health information, into a Microsoft managed, large language model without a lot of privacy protection. And one of the things that we see as a significant opportunity, and also, it's a business opportunity, but it's a significant opportunity to do more with data, which is really our mission for our customers in the world. Synthetic kind of bridges one of the real gaps around how you can potentially use a large language model. And we're seeing kind of explosive growth in that respect. And I can walk you through what that model looks like too.
Yeah, I want to dive into that. Before we go there, like, it is a mind bend, right? To say that you can create synthetic data that's as good as the identifiable data, if you will, right? Like, you know what I mean? You're saying it has all the same characteristics, but not the, like, those feel at odds, right? Like, just on its face, it's, it feels odd. Like, help us understand what the process is, or I don't know, like, to help us understand how that can accomplish that without, having the identity there.
Sure. So let me start by saying it's not magical, and it's also not perfect. Mm-hmm. There are certain times when you wouldn't use a synthetic cohort for many reasons, and I'll get into that here in a second. But the process, is really around developing synthetic output. The process can work in one of two ways. The first way is you have a large-scale cohort, pick a therapeutic area, for example, and you've got lots and lots and lots of features that you want to study, an unlimited number of features. An advance that we've made from a synthetic output standpoint is we're able to take, by therapeutic area, we're able to take a very, very large number of features and build a synthetic data lake that looks remarkably like the original data lake that those features are pulled from. And we do that through a combination of sampling and using GANs and a series of techniques to create a data lake. Again, that if you look at all of the features and start to compare them, they will tell the same story as the original data lake. And that's a kind of, again, a multi-process set of steps that we take to generate that lake. It takes a couple of days. It's a large scale kind of services and technology lift to get a data lake out. We've done that now, 5 to 10 times. It's brand new technology that we've developed over the last year. And it really helps. We are in a project today called VChamps through the VA, where we've done this exact thing. And they've released a large scale cardiovascular data set to the FDA and an FDA partner in England, MHRA. The comparison work that's going on in the use of the synthetic lake that we've created. Now they have a kind of lake that tells the real story, and they can make it available to innovators who are trying to solve a problem related to CHF readmission, and or the use of particular drugs to better manage patient populations. That framework in existence and really interesting, and that's process one. Process two is our classic model, where it's not the full lake, it's not all features inside the therapeutic area. Instead, it's a defined set of features. Now, we call this a precision cohort. And the reason we call it a precision cohort is the synthetic output that you can create, and I'll walk you through the process in a second, is like to a T, with the right sort of values associated with scientific certainty lined up with the original data. The lake is a bit more like horseshoes. The precision cohort is a precision guided munition. Now, the way we generate the precision cohort is, again, it's not magic. We know what the shape of the original data is because it's loaded into the MDClone platform. And if you've got 10 features, what you need to worry about is a correlative outcome that, where you're comparing one feature to each other feature and then one feature to all features. And that's what a 3D, like a shape of data would look like. What we do, and it's difficult, again, it's not magical, but it's difficult and it takes a ton of technical prowess. What we do is recreate the shape of the original data and fill it with fictional data. But the trick is that fictional data, again, has to tell the same story one-to-one and one-to-many across the features that you selected. So that's kind of the synthetic process. The other capability that we brought to bear to make all of this a reality is we can generate it in 5 seconds. So the technical prowess, included the statistical knowledge and included the workflow around, okay, how do we pull that data fast? And then how do we generate that synthetic data so that people aren't waiting around?
Interesting. And when is it best to use synthetic data versus not? Is it more about research? Are you seeing it used directly with patients? Or, is there a time that, hey, yeah, we need the real data, not synthetic data? How are you seeing that kind of play out?
We see the use of synthetic really proliferating in a couple of different moments, but probably the most important moment is hypothesis testing. Hey, well, 2 moments. One, hypothesis testing. Hey, I've got an idea. I don't know if there's a there, but I want to start to play. And that moment happens in quality improvement, it happens in performance improvement, and it definitely happens in academic research.
Yeah.
Now,
we hope accountable care organizations, if they
absolutely. Well, yeah. Hey, what if we rejigger the way we do phone calls for patient appointment reminders, so that, like, what if we did all the calls in the morning instead of any in the afternoon? Would that have an impact on our appointment rate or our no-call, no-show rate? That's an operational question that, I wonder, and I use that as an example. We have customers that use our tooling for that all the time. If you are not allowed to see real patient data and you've got that question, like, what does that look like in a health system? Today, that looks like an IT project that somebody has to spin up. Some, talented, really smart, creative employee, she's amazing. She's like, hey, wait a minute, I think we should be calling in the morning. And then her boss, she says, well, prove it. Why? And great, how do you do that? How would she prove it? She would put in an IT ticket to get a data set, and then analysts would have to spin it up. And it's like, well, is it all phone calls or is it just the appointment reminder phone? Anyway, there would be a ton of complexity built into this one question. And 6 months later, maybe she'd be able to prove it. Like, our job is to make that 6 minutes. Like, if she wants that answer, she's got to go get it. One of the things getting in front of in her way is, wait a minute, is she allowed to see the real patient data or not? With synthetic, that gets pushed to the side. So those use cases like that, they've proliferated. There are tons of those examples. That's where and how people are using the tooling. What we're seeing that's of interest is, hey, wait a minute. I want to do that analysis, but I don't want to actually do the analysis work. I have my creative, smart idea. How can I leverage a large language model to actually flesh this out, to act as my, kind of world's most powerful research assistant, to take all of human codified knowledge and apply it to a new little data set. Again, in a world where you have privacy concerns, you cannot load that data set into a large language model. But what about a synthetic data set? Can you load that into a large language model tool? And can you allow that large language model tool to go mine it? And that interest area is blossoming is the wrong word. It's exploding.
It's a very quick blossom. Yeah, I mean, let's talk more about that, how you see these large language models and the synthetic data working together in healthcare. Is it about feeding the large language model with more data, but because it's synthetic, we can do that? Or do you see other uses, ways that those two are going to play together?
So that's the first one. And I think there's a ton of work for us to do in that space, right? How do we make healthcare data, real-time healthcare data, available to a large language model? Synthetic's a great answer.
Well, and I heard one person, I think it was H2O AI, said that when they do this, they said you need your own language LLM. Your own LLM for your organization, or maybe even every doctor needs their own LLM that's based on how they practice, which that blows your mind too when you start. We have individual LLMs, and how are you going to get the data to build those? I think synthetic's an interesting option.
Yes, and I think our synthetic lake opportunity is more in line with the training, which is really where maybe that quote that you shared, maybe they're heading towards, how do we train this language model so that it delivers the clinical advice in the voice of the physician who's ordering it. When she finds whatever she finds, it can really sound like her, really act like her. I think that's really interesting. I think that fruit may be further up the tree, though, John. I think the lowest hanging fruit is leveraging the power of the model itself to get to better quality and or better performance and or better research. I mean, I had an opportunity to join a Future of Health conference a couple of weeks back in Boston, hosted by Beth Israel Leahy. And, I got a chance to see them leverage in an example and a demonstration, a company called Hippocratic AI demonstrated using a large language model to in effect, handle prep prior to a procedure, patient outreach call prior to a procedure, and have that large language model interact with the patient. And it was a colonoscopy, and it was a question about the prep and if they could use Miralax versus the actual prep, and they played it out. And it was a cool example, but the business case was, hey, for a nurse to have that conversation, it's $90 or $120 an hour. If I have a large language model having that conversation with the capacity of, a nurse, with good or better, not perfect as the goal, maybe that's $1 an hour. Hey, we can find a business case. Well, I was scratching my head thinking, well, gosh, to get knowledge work out, if you're a data scientist, if you're an analyst, the data wrangling piece and the building the visualizations, if all of that could be done by a large language model, because none of that is a commodity. Which graph should I use to show this point? Like, that is perfect for an LLM. Perfect. It's not asking you to explain Einstein's theory of relativity. It's simply, hey, I've got 15 different graph choices. LLM, what's the best one to use for this specific? And that could be like 4 weeks of work for analyst land. Like, if you can shrink that to 4 seconds, that is a major cost saving. And it creates this opportunity for way, way, way more value. If I can do it in 4 seconds, well, how much more could I do? that becomes the interesting question. Anyway, I think that's the first layer of the tree where there's real fruit.
That's interesting because, and I think that, we sometimes look at large, and this is a mind changing perspective, right? To think about how we use this technology. Because you're right. If you feed in 10 charts that say all 10 of these are accurate, which one's the best? That's a different way of, like you don't have the hallucinations because you already fed in 10 charts that are accurate. It's just helping you do it, understand it better and analyze it better. That's really interesting. Looking at this another way, and you've talked about a couple examples, so I'm really curious. Do you think that the large language models and synthetic data are going to be used at kind of more the population level? I mean, your data lake kind of an example, or do you see it kind of at the individual patient level that, the doctor's going to be using these LLMs to analyze and treat patients, or maybe both? How do you see that? Because the data has been interesting, right? I mean, MDClone's been on this data journey for a long time.
Yeah.
We started with data warehouses that nobody knew what to do with them. And so we collated all this data, and a lot of them didn't get value out of it, right? We'd have EHRs that are very patient specific, obviously trying to bill and a few things like that. So, where do you see this LLMs and synthetic data? Is it kind of more population size or individual patients?
All the above. I mean, so first of all, the beauty of the way that the OpenAI and now Bard, the way the tools are constructed is it's conversational. So you can ask whatever question you want. And again, it's drawing on the corpus of all human codified text. Okay. Up until 3 years, something like that. So I don't see a distinction between population and patient. In fact, my wager is, and I'm sure you talk to a lot of physicians as part of this podcast, as soon as they got their hands on ChatGPT, for instance, downloaded on their mobile devices, my suspicion is the bell-shaped curve looks a lot like 95% of them asked diagnostic level question. If a patient presents and looks like X, Y, and Z, and their temperature is, 100, and they were visited, et cetera, clinical scenario, what's the right course of treatment, or what's the right diagnosis, or what are the chances of X? You better believe 95% of that bell-shaped curve ask questions like that, because that's their work. They ask questions like that all the time. And so, of course, they would ask them to other people, other consultants, ask them of their EHR and clinical decision support. Like, that's so much of their work. Of course, they will leverage these new tools to ask questions like that. And I'll bet they judged the response, with their clinical background, they judged that response. And so, we would be naive to think that these tools aren't going to be used in that capacity. They are. And again, better is the goal here. They are going to be used in that capacity. And we have to do a really good job of making sure that these tools are, used correctly, one, and two, that are giving accurate results. But they're going to be used that way. And they're going to be used for a ton of pursuits that are population level, research pursuit, population behavior pursuit, epidemiology. I mean, and they should be. Again, the beauty of these tools is the interaction point, the UI is it's a chatbot. I mean, it's genius.
Yeah. Well, it's funny you say that because I have a statistics professor friend that was talking about neural networks early on. This is, 4 or 5 years ago. And I was asking him about a project. I said, if we give you all this data, can you output, can you look at what's interesting with the data? And he, or can you focus on these specific things? He said, John, no. He said, you give me the data. I'll have the neural networks run on it. And then I'll tell you what's interesting with the data.
Yeah.
And like, I heard him say that. I understood what he's doing. I didn't know why that would work. But I think to your point, the beauty of ChatGPT was they made the interface so anyone could experience that across all of human knowledge, right? So to me, that's what makes this exciting, is it's opened up the creativity and the accessibility of this technology that's actually been here for a couple of years.
Amen. I think you got it right. And I think your statistics friend, I sometimes flippantly say, hey, do you want to ask the questions, or do you want the super fancy smart machines asking the questions to help you figure out what's the right questions to ask? And maybe I should be a little less flip with that, because I think that is where we're heading. But I think we want both, right? We're amazing creatures. Humans have this innate creativity, at least in some of us, not named me. And you want to foster it. And it's, that's part of the kind of beauty of being a human on planet Earth in 2023. And we want, more, better, smarter, faster knowledge. So you gotta work with the tools you have. And this is a very powerful new tool.
Yeah. Well, I mean, I guess I should disclose that I did not use ChatGPT or an LLM to create the questions for this podcast. I don't think you did for your answers either. But it's funny, we actually have done that for other podcasts, and it comes up with interesting topics, but not very novel. So I think that was an interesting take there. But Josh, yeah, go ahead.
Well, I first of all, I should say that there is no replacing the human at the wheel here. It all falls apart without 2 eyes and a brain to screen, validate, get to the experience level. We're not there yet. We're not going to be there anytime soon. Maybe never. It requires the human touch, because we're humans. So, and we can sniff out when it's not human, always.
Yeah. Well, and the creativity of the humans to use the technology in really interesting ways, that's what never ceases to amaze me. And I think that's been true with every technology. So, we're on that curve. So, well, thanks so much, Josh. This was a fun conversation, a good dive into synthetic data and LLMs, and appreciate you taking the time to share your knowledge and insights. And thanks everyone for watching and listening. If you want to find more great healthcare IT content like this, be sure to check it out at healthcareittoday.com or search for Healthcare IT Today on your favorite podcasting applications. Thanks, Josh.
Thank you, John. Take care.